Hello, in this video you are gonna learn how to create this app in PyQt5. This is a simple recreation of the Photoshop spot healing tool that can help you remove unwanted spots, marks or small objects from your images. It works by automatically sampling pixels from nearby area you clicked and blending them with the target area. You can use the spot healing tool to quickly and easily remove blemishes, dust or other imperfections from your photos. Though this app itself might not be big, you will learn a lot about PyQt5 and how to make a proper GUI application. Now let's get started on the code. Create a main.py file and include the necessary imports. By the way, this is not a beginner tutorial on PyQt5, I recommend you learn more about it if you are a complete beginner, but I will try to explain as much as I can. Let's create the main class that inherits from QMain window and set up our default variables. This history list will store the history stack, which we will implement later. It will allow us to perform undo in our app. And these flag variables will be used to create panning in the image view window. These features are extra polishing that you can ignore if you want, but after I implement these I fix an issue at the end of the video which you should watch. Now let's set up basic window settings and add the needed widgets. I am using QGraphics View instead of a normal QLabel and Pixmap because it allows us more flexibility, and you can basically add unlimited features. We are going to have a QGraphics scene attached to Graphics View and add a Pixmap item inside. Reassign these event methods to our own so we can control when we click and drag our mouse. And wheel event for mouse wheel zooming. This function will create a black circular mouse cursor depending on the radius. It's very simple and a good visual indicator for the user. Let's have a preview of what we have. Make sure to define all the method we manually assigned. Now for the radius changed method. This is a reminder to call save state method, which we define later. It should save the current state every time we change slider for undo operation. Let's add the image loading options and methods. We also need a separate method to update the image preview from our image variable. First, convert the color from BGR to RGB as OpenCV reads it as BGR image. Then we can convert it to a Q image and set it to a Q graphics pixmap item inside our scene. We need to define our image item variable, which is a Q graphics pixmap item. It looks like we have a problem in our load image method. Let's fix that. First, check if image is valid or not and if left mouse button is pressed. Then we convert the mouse click position to scene's position using the map to scene functions from our image view, which is a Q graphics view. Then we can convert it to int and check if it's inside our image's bounds or not, meaning if we clicked inside the image or not. If so, we can activate healing brush tool flag and heal our image. Then update the image label. These function names are from my old code, so they might not make sense here. We will create a new thread worker to do the actual healing in a different thread so it doesn't lag the UI, as sometimes for big images it could take time to process. Let's create a new worker.py file and define our QThread class. This is a signal which we will emit after image is processed. We can listen to this in our main thread window class and set and update our image. It returns an ND array, which is a type from NumPy, as opencv returns 1. In here we don't actually need to take reference to update image label method, as we call it in the main class. I had it in my previous code, you can remove it. Then we define the variables that will be used in the main function. You don't really need to define them in init method, but I am doing it to avoid attribute error just in case. In this healImage method, you don't need to take x and y as argument, you can use the classes x and y variable. But follow along so you don't face any errors. These things I forgot to update before recording. Now for the heal function, first we check if image is valid. If so, then we create a mask with the help of NumPy. With 0-like function, it will create an image that is completely black of the size of our current image. Then with the help of opencv, we create a circle on the clicked position x, y. It will be completely filled with white color. -1 is for filled and 3255 is for white color with our given radius. This will create what is called a mask. We are basically indicating that the white areas are the area that we want filled with new pixel. Then we can use opencv's inpaint function to do just that. Pass our image, then only pass the binary mask by passing the first channel from mask variable, then sample radius, and use the inpaint tailor method from opencv. We save our x and y radius, which is just our normal radius. You can use self-radius if you want. Now finally it's time to replace the part of our image with the new one that got generated from inpaint method from opencv, which is saved in source area variable. Inpaint method basically sampled nearby areas pixels to fill the place we clicked, basically the masked area or the white part of the image. Make sure you do this part properly, otherwise you might get weird results. For the source area's square brackets, you can copy the same code from original image. This is the bare minimum of the algorithm and is a little bit faster, but comes at a cost, which I show later, and also show a fix, which is already integrated in the final version, so make sure to watch that part. Then emit the done signal with our new image. Make sure you override the run method as is. This method automatically gets called when you call start method on QThread. In here we call the heal function. Then we have a separate method that lets us set our variables each time and calls the start method. Now let's import our worker, then connect our done signal to process done method. In this method we just set our new image, then update the view. As we call the update view here, we don't need to give it to the worker. Now in healImage method of our main class, we just call set and run method and pass our variables. Let's work on the rest of the mouse event methods. In the move event, we can check if image is valid again, and if healing tool is active, then just do the same thing without setting the healing flag. And for the release we just turn off healing flag. We are also going to have a way to undo, so this comment is to remind us where to save the state. Let's test our app so far. It seems like it's working. Now let's implement the zooming functionality. We check if mouse Y of angle delta is greater than 0 or not, which means we are zooming in. We also have a zoom in limit via using zoom level variable, which you can ignore if you don't want to, as it somewhat complicates things. If you don't need to have a zoom level variable or don't want to limit your zooming, you can comment these out and it will still work. Now we can zoom in and out by using our scroll wheel in our mouse. Let's add panning, so we can press space button and drag around our image view. When space is pressed, we set the flag to true and change the image view's current drag mode. Now in mouse press event, we check if left button is clicked and if space is pressing. If so, we save the current position and turn on dragging flag and return. This return is important as we don't want to execute healing when we are just panning around. In move event, if we are dragging, then convert both the image current mouse position and last position, and subtract them to get the delta in between, save that in delta variable and update last cursor position again. Now we can translate our scene view to that new delta. For release, just disable the flags. Now it seems the panning is reversed, it's going to the opposite of where I am dragging. To fix this we need to negate the delta. It's now working. You can also see that the spots are sharp-edged. It's too visible that it was edited. After adding undo support we can fix this. Now let's create a state class that just has all the attribute to hold all our important variables that we want restored. It will take our app and manually assign those variables to itself. I will warn you that this way of storing history stack is not memory efficient. You could update it yourself and most of the code could stay the same. In the saveState method, we just create a new state instance and pass it our app, and append the state to our history, which also doesn't have a limit on how many states it can save, but ideally it should. You can take these small features and fixes as a challenge and try to do it yourself. In the load last state method, check if history is empty or not. If not, then call the pop method, which will give us the last element and also remove it from the list. This in turn will not allow for redo functionality. If you want redo, you could just manually get the last element and not remove it, and in redo method, just reload the second to last element. After getting it, we manually reassign the values and update image view. Let's now add a shortcut to reload last state via Ctrl+Z. The undo is not working. Let's fix it. I accidentally put a comma instead of a plus here. And forgot to save state at all. Just call the save state function on commented places. It's working now. Now let's work on fixing this rough edge issue and add support for opacity slider for our brush, and most importantly a save button to save edited image. Now we can save our images. Let's work on fixing healing tool rough edge issue. Let's comment the old method and create new. The name should be same and it's gonna take one extra parameter called opacity. Do the usual checks. Creating the mask part is same, but this time we will create a feathered circle instead of a normal mask circle, so it's gonna have smoother edge instead of a sharp one. To make the circle smoother, we just add some Gaussian blur to it. And you can adjust this 0.6 value to get different results. Now in this extra step, we are going to blend source area with original image using the mask. This should make our healing tool significantly better. Now for the image copying part. We copy the newly created image to our original, but this time we are going to integrate our opacity value, which will basically control how much of it we want to add or blend with original. Again, make sure not to make a mistake in this step. And we are done. Just emit the done signal and pass the image. Make sure to take the opacity value in set and run method. Time to add a opacity slider. It's going to be a little different as it should only take from 0.1 to 0.5. You can go higher than that, but things might start to look like before if you do too much. Forgot to add the opacity slider layout to main layout before, make sure to do that too. We also need to update our state class and load method to take in our opacity. And finally pass the opacity to set and run method. Now everything should be working fine. You can see our results are much smoother and much less noticeable. Thank you for watching. If you made it this far, a subscribe to this channel is appreciated. I try to cover topics that isn't done by many, so you can expect full-on tutorials like these.